Hey guys, and welcome to the FTCsim programming tutorial for Movement Level 1, but with encoders. This video is more of a how to use encoders in the FTCsim and less of an explanation video on how encoders work. Using encoders is useful so we don't have to use sleeps and motor powers to move our robot. In the FTCsim, moving with sleeps and motor powers is fine, but in the real world when working with battery drain, the robot will have less power to drive those motors, making the sleep/power method inconsistent. Using encoders will mean our motors will move the same distance every time. We'll go ahead and start out by reversing one of our motors on initialization and making a function. Basically what a function block does is let us make code in this block here, and then we can call it later by using a simplified block. We will call this function drive with encoder. And we will start building our encoder code inside. First, we'll need to go to our actuator tabs, and then DC motor, then the dual tab, and we're going to go ahead and grab our set mode, run using encoder, and drag that inside of our function block. And we are going to change the mode from run using encoders to stop and reset encoder for both left and right motors. What this does is clears any previous readings from the encoders. Now we will go ahead and add our dual motor block where we set our target position. Which will just be how many ticks we want it to go. We will leave the zeros in for now. Now we're going to tell the motors we want them to move to that position. Go ahead and grab our mode block from the dual motors tab and change the blocks to run to position. Now we are going to tell the motors what speed they will need to do this maneuver. We will go ahead and grab our dual motor set power block and we'll leave these at 0. Now we're going to create some inputs we want for our blocks. And this will also generate our variables. We're going to go ahead and click our little cog here in our functions block. And we'll select how many inputs we need. We're going to use 3. Can go ahead and drag these guys in here. We can see they'll automatically name themselves, but we're going to change those names. Go ahead and do left target, right target, and speed. And now if we check our variables tab, we can see all of our variables. We're going to take these variables and plug them inside of our function. So we're going to take our left target and plug it into our target position block, motor left. We're going to do the same with the right. And we're going to replace our zeros in our set power with some speed variables. Instead of putting in a sleep to let this function do its thing, we're going to use a pause in the program while it's doing all of its stuff so that we don't have overlapping code or commands. We are going to grab our repeat while loop out of our loop tab. So what we're going to do is build a condition that we want our loop to pause at. We can think of it like we want our loop to pause while the op mode is active and the left and right motors are busy. So let's go ahead and grab some logic blocks here. We have 3 different things we're going to be monitoring, so we're going to need 2 of these blocks. We can go ahead and nest one inside the other. Now we'll need to grab our blocks that correspond with what we want to monitor. So our first one will be that while our op mode is active. So this is going to be in the linear op mode tab. And it's the call simulator op mode is active. And our next two will be while the motors are busy. We can find these blocks in the DC motor tab. Don't forget to make one for your right as well. And we can plug this into our equation. And we will plug the completed statement into the while loop. Now we will put a pause, or as the system calls it, idle block inside of our loop. We'll grab this guy from the linear op mode tab, and it will be called the simulator.idle block. So for this, we don't need a breakout block in this particular loop, since it has an end condition when the motors are no longer busy. Now we can use our function. We can grab our block from the Robot Functions tab and plug it into our code above the loop block where we put our run blocks. And now we can grab some number blocks and put them in for our inputs. And now we can test our code with different target positions and speeds. On your own, experiment with the right target number to complete this first stage. Now what I can show you is how we can bring this code with us to other levels. We should be able to copy this block using Control-C. And Control-V, and we should be good to keep using the encoder code. Here is another handy trick. We can create a left and right turn function as well with minimal code building. If we grab a new function block, we can name this one left turn. And now we can take our drive with encoder function and place it inside and figure out the inputs it takes for us to get to a 90-degree left turn. Now we can just put a single turn left turn block and we can repeat a process for a right turn block. And now we can take this with us to other levels. Don't forget to save your work Thanks for watching and see you guys next time.